What's up, guys? Beautiful day to be learning some math here at San Diego State University. I'm Andrew.
I'm Katrina. I'm Nicole. I'm Emily.
And we are here doing our math trail project. So today I will be exploring some stuff with chapter 16 of polygons.
I'll be doing chapter 20 on scale factor and chapter 25 on formulas and the volume of a cylinder. I'll be doing chapter 18 on symmetry. I'll be doing chapter 17 on pyramids.
Hope you guys enjoy it.
Hey guys, we're in the bookstore at San Diego State doing chapter 20 on the scale factor. Right here we have two bags. The scale factor, if this is the original and this is the new one, we're going from a small object to a large object, so the scale factor would be larger than 1. If this was the original and this was the new, we'd be having a scale factor of less than 1. We know that they have a scale factor because the angles are the same, because they're both rectangles and the sides are congruent. Hi guys, we're over at the makeup counter at SDSU bookstore. Right now we're talking about chapter 25 about volume of a cylinder and the formula. Right here I have just a foundation, and it's going to be volume equals base times height. The base is actually going to be 2 pi r squared because there's two bases, and the area of a circle is pi r squared. So once you figure out what this is, you can times it by the height, and that's how you would figure out the volume of a cylinder.
I'm doing symmetry on chapter 18, and I'm going to use this journal to show you how and why it has symmetry. For this journal, it has symmetry because when it is cut or sat at a different point, it's exactly the same as the original. For example, if you open up the journal and you cut right down the middle, the reflection of one side is the same as the other, and if you cut down the middle here, the reflection is the same. For rotational symmetry, if you have the journal at a point here and rotate it 180 degrees, it looks exactly the same as when you had it at the original. If you rotate it 90 degrees this way, it doesn't look the same, but if you rotate it again 180 degrees, it looks the same. Also, this journal has planes of symmetry, where if you cut it down the middle of the journal, both sides would be exactly the same, and also if you cut it down the middle here, both sides would be the same. So on to Emily.
Okay, so we're still in the bookstore. I'm going to be covering chapter 17, talking about prisms. So in front of me is a right rectangular prism. It has 6 total faces. 2 of them are bases, 4 of them are lateral edges. There are 12 total edges, 4 on the base on the top, 4 on the base on the bottom, and 4 lateral edges connecting the 2 bases. There are 8 vertices, so 4 on the top and 4 on the bottom. The vertices connect the lateral edges to the bases. And that's all we have to say about right rectangular prisms. Next we're going to be going to Andrew.
Covering polygons, chapter 16. We're right outside the Love Library. I'm going to be using this plaque as a representation of sum of interior angles. So if we take this square right here, all angles are going to be 90 degrees because we know it's going to be 360 degrees in our quadrilateral. Also, to go with this, we need to have 4 congruent sides and then also 2 pairs of parallel lines. So that pretty much sums up interior angles. Exterior angles. Alright, so we just covered the interior angles. We know that it's going to be 360 degrees. We got 90 at each corner, but when we're talking about exterior angles, you're going to be talking about the 180 degrees that you're going to be covering. So let's say that we start with this angle right here. We know that this is 90. If we go on this line segment of 180 degrees, then we also know that this is going to be 90. It's complementary and supplementary angles. What's up, guys? Back outside the Love Library. I want you guys to take a peek up the clock tower. You can see up there we got a pyramid, and I want you guys just to specifically pay attention to the faces. You can tell that the face of the pyramid is a triangle. So I just want to cover the interior angles of a triangle. We know the sum of all interior angles is 180 degrees. There's multiple different triangles that you could talk about, equilateral, scalene, isosceles, whatever it may be. But no matter what, the inside of a triangle always has to have 180 degrees. A way that we can go about this, and also that we covered in class, is talking about n, the n value. If we take n minus 2, multiply that by the amount of sides that we have on that, we will also find the sum of the interior angles.
Hi guys, so we're outside the library. I'm talking about the difference between a prism and a pyramid. So the difference between a pyramid and a prism is the prism connects two polygonal bases. If you look at the top of the clock tower, the top of the clock tower is a pyramid, and it's a polygonal base that connects at the top to an apex.
What's up, guys? Back outside the library. We'll be using this as my example. As we can tell right here, it's a rectangle. Simply just want to go over the pure definition of polygon. Polygon is a closed planar figure made of line segments with no crossing. So obviously here we can tell there's nothing that's crossing about it. It's just regular polygon. Say that we're going to be going over concave polygons. Cut out a section right here. That would be a concave. Convex would be saying if we had something coming out, so say it was like a pentagon. Simple as that. Pretty easy definition, but at the same time, also a great example. And then if we're talking about segments here, there's no diagonal segments cutting through the shape itself of the polygon. Regular polygon. Alright guys, back where we started. You guys just watched a video of our math trail project. I covered polygons.
I covered scale factor and the volume of cylinder.
I covered symmetry of a shape.
I covered prism.
Hope you guys were able to learn something, maybe review some material that we've gone over in class. Appreciate you guys watching and have a great rest of the day.